for Year 11 Advanced. Confusing at first. Okay, so it won't be like calculus, where I just said, oh yeah, bring the power down and then just take away 1. I mean, that kind of makes sense. It's not going to be like that. It will be a little bit confusing at first. So you won't really get it this week. You'll get it really well next week, which means by the time we review it the week after, that's probably going to be your best week. So just give this one some time. So the first thing we've got to do is just review of index laws, which I think is pretty easy for us. Product, what do we do when we multiply bases?
Add them.
So multiply, you add the powers, divide, you subtract the powers, power to a power, you multiply, anything to the power of 0 is 1. If you've got a negative index, it's the same as writing a fraction, so 1 over a to the power of a positive index. And if you've got a fractional index, so be careful with those two, if you've got a fractional index, it is the xth root of a to the power of 1. Or in other words, if I've got a to the power of p on q, the q goes on the bottom and the p goes on the top. Okay?
Yep.
A slightly more neglected rule. We say that because a lot of students actually are not very strong with this version. So ab to the power of x is the same as a to the power of x times b to the x. That kind of does make sense, but a lot of students don't see this. 6 to the x is actually 2 to the x times 3 to the x. So if your bases are different, as long as your powers are the same, you're allowed to multiply your bases. So I like this to be a rule as well, and that's how that one works. So if your bases are different, so not like this one here, this one your bases are the same. This one, if your bases are different, as long as your powers are the same, you're allowed to multiply them. And that becomes that. I'll leave some of these index laws questions for you guys to look over. Maybe we can go through it next week. I'll prefer to just start off with our logs today. Okay. The first thing you'll probably learn, and you probably, for those who did logs in Year 10, you probably did learn it this way, is the definition of how to convert from an exponential to a log. Now, I probably won't be using this. So I won't be using this definition. We are going to prove it every time. Now, it might be a little bit harder at first to prove each time, but in the long term, all of the questions you'll probably get in your exam require you to do a bit of, let's just say, math. So therefore, you won't be able to move from one to the other as quickly as you can in the basic definition. So you might as well learn it from the proving way from the beginning, so that as you come to the harder questions, it's almost second nature for you. You don't have to learn a new method. So this a to the x equals y becomes x equals log ay. You won't see me go from here to here in one line. So if your teachers, but your teachers will, so just be careful. We don't do it that way. We do our things by actually understanding what's happening and how to move from here to here. All right. So the laws of logs, just like there was index laws, there's log laws. They're not too hard. This one says log x plus log y. So if you add two logs, you're allowed to multiply the terms in the inside. So adding two logs, you can multiply it. Or if I've got log of two things that are multiplied, it's the same as saying, let's add it. Add two logs. Same thing when you subtract. Log x take away log y becomes, of course, log x on y. These two, a lot of students just know very well because it sounds similar to your index laws. This one here is a very, very important one. Powers. If I've got log x to the power of a, I'm allowed to bring my power down. And that's really useful because all of a sudden it's not a power anymore. It's just it's like a coefficient almost, right? And you brought it down. If this is a base and this is a sub-base, this was a power, so be careful, this is a sub-base. If this sub-base and this base are the same, it's always going to equal to 1. Again, we will prove this from the way we're going to do our math, but you can memorize this. If these two numbers are the same, then it's always 1. Base and sub-base, not powers. Logging 1, if you go into your calculator right now and you just put log 1, it will always give you 0. Doesn't matter what this sub-base is. So let's see how these things work. For example, if I said log of 2x, Lisa, log of 2x. So it's been multiplied. How else can I write this? Log what?
Log 2 plus log x.
Yeah, right. That's that simple. Or vice versa. If I ever came up to you and said, hey, log 2 plus log x, you're going to say, okay, if it's plus, I know I can just multiply the two things, which is log of 2x. So let's do that. Log, 3 minus log x. Well, log 3 take away log x. Rad, log 3 take away log x is log
3 on x.
Yep, it's that easy. And then if I said log of x to the power of 3, Tiana, log x cubed equals, what are you allowed to do with powers?
Bring it down.
Bring it down, so it becomes?
Log 3.
Ooh, just bring the 3 down. So what's that first?
Just 3.
3, and then you just write log x, that's what's left.
Yeah.
So you're literally bringing the 3 down. Whereas when we're doing calculus, we brought it down and subtracted 1. Here, you can just bring the power down, and that's it. Awesome. And then if I've got this one here, for example, log, 2 and a sub base of 2. Okay, this is a power. So you guys will learn that. These are all in the same line, and then a power on the top. Same line and a sub base at the bottom. If it's like that, Eden, what's the answer to log 2?
1.
1. And then, of course, log of 1, it doesn't matter what this number is always going to just equal to 0. All right, let's actually see this used in questions. Example 6. Given, now, first thing is getting used to these sub-bases. Can you see how all of these sub-bases are all A's? Because they're all the same, for now, especially because your first day, they don't actually matter. You can completely ignore them. They will matter to you if they were different. Like if this was an A and this was a B, I would say, hey, be careful. But for now, most of the questions you'll see, they are all going to be the same. So we can ignore them just so you can write a little bit neater. The way we do say it, if you want to have the A in there, I say it like this, but your teachers might say it differently. Log 2 sub base A. Sub base. Log 2 sub base A equals M. But I'm going to start ignoring the A. I'm just going to say log 3 is equal to M. Just so it's a bit easier for us to read and understand today. So log 2 equals M. Log 3 equals N. The question says, write the following in terms of M and N. So log 4. Now the way these work is all of these are these two just hidden. And you've got to work out how 4 is linked to 2 or 3. How 18 is linked to 2 or 3. How 12 is linked to 2 or 3. How 27 is linked to 2 and 3. Cool? So that's how these work. So the first one, log 4. I've got to work out how do I bring log 2 and log 3 into log 4? Anyone have any ideas? 4. It's a special number. No? Oh.
Is it the first one? Because it's just 2 times 2.
Okay, good point. So, and I'll show you, you aren't incorrect. So log 2 times 2 is log 4. Lisa, stay on with me for a second.
Okay.
So log 4 is log 2 times 2, and then what do you write? Log 2 plus log 2?
Yeah.
And then what's log 2 equal to? Yeah, log 2 equals to? M.
Oh, M, sorry.
Yeah. So M plus M, which equals?
2M.
And that's the answer. But I want to say in a different way, watch this as well, which is absolutely fine. So don't think that's wrong. That is full marks. Another way, 4. What's another way I can write 4 other than 2 times 2?
2 squared.
Beautiful. And then what are you allowed to do with squares? Or what are you allowed to do with this power?
You bring it down.
Bring it down. What does log 2 equal to?
M.
What's your answer?
2M.
Good job. So you guys can see 2 different methods. It doesn't really matter what you do, but the idea is log 2 and log 3 are hidden in these numbers, and you've just got to get them out one way or another. Any questions before we move on? All right, let's have a look at B then. Log 27. Who wants to try that? 27. Think about 2 and 3. How is 27 linked to 2 and 3? If you don't know it, get your calculator out. Maybe do some multiplying, do some powers until you get to 27 using 2s and 3s. In any combination you like.
Very cute.
Done. Log is 27 is 3 cubed. Bring the 3 down. And then again, my question is going to be, what is log 3? Log 3 is equal to n. So the answer is 3n. And another one. What I'll do, because it looks like I'm running out of space here, I'll rather start a new page. I'm just moving it. Okay, C. Log 1.5. Oh, that's kind of obvious. Anyone? Log 1.5. 1.5.
Log 3 minus log 2.
Oh, beautiful. But, so log, just to make it a bit slower, log 3 over 2. And then 3 over 2 is log 3 minus log 2. And then what's your answer?
N minus m.
That's it. Because it says write the following in terms of m and n. So you have to have it in terms of n and n. Good job. D. Any questions? Please stop me. If something's confusing, just stop me. Log 12. Log 12. Who wants to try that one?
Would you go log 2 squared plus log 3?
I love it. Plus, wait.
You close bracket and then plus log 3.
Yeah, plus log 3. Anyone confused about that? What he's done, he's gone 4 times 3. 4 times 3 is, 2 squared times 3. And then because we're multiplying, we know we can add it. And then, next line, what are you going to do?
Drop to 2, so go 2 log 2.
Plus log 3, but what does log 2 equal to?
And log 2 is equal to m, and log 3 is equal to n.
Too easy. E, log 18. I'll do this one. Log 18 is, again, log 9 times 2. Log 9 is log, well, we'll just go like this. But 9 I know is 3 squared. I know bring the 2 down, and then log 3 is n plus m. Log 13.5. What are you going to try for that one? What, 13.5? Yeah, 27 over 2. 27 over 2. So that becomes log 27. Take away log 2. You already know log 27. We worked it out here. It's 3n. Log 2 was n. So you're kind of done, aren't you? 3n, take away m. Easy. Let's look at a HSC question. Boom. All right, HSC, question 7. Have a quick read of it. And again, just for your comfort, at the moment you can ignore the A when you're reading it, but I'm going to keep the A in there just to show you how we work if we're going to write the A's. But it doesn't make a difference to you because they're all A's. All right, let's go. 2-unit HSC question 7. Given log B is 2.75 and log C is 0.25. Find the value of log BC, B on C. What do I write? Who wants to get a mark for their HSC?
Is it log 2.75 minus log 0.25?
Ooh, okay. No. You've got it right in terms of what you're minusing. So wait, B on C. You know that's log B minus log C, yeah?
Yeah,
What does log B equal to?
2.75.
Yeah, what does log C equal to?
Oh, okay. Yeah.
Whereas you said log of 2.75, log of 0.25. Just be careful. Because that's another thing. Like we will be logging numbers soon, but this one is actually log of like B is 2.75. So, and if I include the A's, all it would look like is this: log B sub base A, log C sub base A equals 2.75. Take away 0.25 equals 2.5. Lisa, that makes sense, right? Double I. Again, I can see it's all squared. Has to be all squared. If just the 1 was squared, you can't bring the 2 down. The whole thing has to be squared. The whole thing is squared. I'll bring it out. Then I'm left with that. I know that if they're multiplied, I can write them as log B sub base A plus log C sub base A. Like I said, try to ignore saying A every time. You're just going to confuse yourself. Log B is 2.75 plus 0.25. That's 3. 2 times 3 is 6. You got yourself 3 marks in the HSC. Go and find it if you want. 1995 2-unit HSC question 7. You'll see it's exactly this. 3 marks. So, hope you guys see. It's not hard to do well. Just jump straight to your exam questions. All right, let's go again. Write each of the following as log 3 sub base 2. So write each of the following like this. All right, log 81. Well, I know 81 is obviously 3 to the power of 4. And then, of course, you just bring it 4 down. 4 log 3 sub base 2. Write each of the following as log 3. There it is, 4 log 3s. So log 81 is 4 log 3s. Okay, log 2 root 3 sub base 2. Okay, this one, it's going to be written like this. Log, well, what's between the 2 and the root 3? What is between the 2 and the root 3?
Times.
Yes, so I'm going to add log. like that. I'm going to add my 2 logs. What does this one equal to, Eden? Log 2. You said it before. 1 plus. What are you going to do with the root? Square root. Want it there. 3 to the power of?
Half.
Yeah, see? And then bring the half down and you're done. 1 plus half log 3s. Because you can only have it in terms of log 3. It does not log root 3. And C. C is log 8 over 9. That becomes log 8, take away log 9. Log 8 is 2 cubed. This is 3 squared. Bring the 3 down. Log 2 is just going to become 1. Bring the 2 down. Log 3s is exactly what you wanted, and that becomes just 1. So your answer is 3. Take away 2 log 3s. Any questions? No. Okay. Let's. Are we ready to move on to this? Yeah, I think so. All right, let's do this. Equations involving indices and logs. Probably the most important law to learn. There is a way, so like I was saying to you guys before, this is a bit annoying, right? Log B, sub base A. You can't actually plug that into your calculator. So if I said, hey, go and find me this, you can't actually plug that into your calculator like this. Your calculator doesn't do this sub bases. So what you want to learn is that you can actually rewrite this as a fraction. So that works really neatly. And it's not that hard. So if you've got log of B with a sub base A, you must learn that that becomes a fraction of log B over log A. So log of the top over log of the bottom. So in this case, this one becomes log 3 over log 2. Now, go ahead and learn how to use that on your calculator. Let's all make sure we can find it and get the same answer. So I'm just plugging it into my calculator. You should do the same thing. Try to see if you can get 1.58. Let me know if you can't get that, or if you don't know where the log button is. It's just on top of cos. All good. Now, before I continue any further, look at the button right next to log. So there's one that says log, and there's another one on the right, which is on top of the tan, that says ln. This is also a log. In fact, they are both logs. Now, the one you will probably see me use is not this one. It's this one, ln. So every time I say log, I actually mean ln. Every time we're writing log, I can interchange, I still mean ln. Now there is a difference between the two, it's in regards to their bases. This one has what we say is a base 10, whereas this has a base e. E meaning exponentials, and logs and exponentials are opposites of each other, just like times is to divide and square is to square root, addition is subtraction, tan is to tan inverse. So log and e are opposites of each other. So that's why I like to use ln instead of log, log. If you want to learn more about the bases, I'm sure there are many videos on that, or your teachers would probably explain that, but we don't need to get into that in this course at all. But what you will probably see me write and say or mean is more ln. So what I want you to do is go ahead and do this one again, but now use ln. So ln3 on ln2. Now it gives you the same answer in this case. Right, confirm that. Now I want you to go ahead and put this into your calculator. Log 3 compared to ln3. And they don't give you the same answer. .0982. Cool. Now the reason why they don't give you the same answer is because obviously the bases are different. But the one that we're going to probably use more often is this guy. You're very unlikely, like maybe less than 1% of the time, you'll ever see me actually use log on my calculator. Even if I'm writing log, like when I wrote this, I didn't put log in my calculator, I put ln3 over ln2. So our method, my technique, most of the time, we're going to be using ln's. If I see that you're using log, you can write it, but if I see you using on your calculator log, it's probably your teacher's method again, and not my method. So I know my method is we just use ln's. Okay. Anyone have any questions there? So back to this bases, you must memorize that one there. So if I've got log of b and then subbase a, I can write that as a fraction, log b over log a. It's really important because to be able to solve, you'll need to be able to convert things into that form. So I'll do an example. Let's say if I had log, well, I'll do an easy one. If I had log 6, 8 equals x. Solve. Can you go ahead and work out what x is? Can someone see if they can find the answer for x? Log 8 subbase 6. Well, what would you do? You would obviously write this as a fraction and then plug it in. What's the answer you got? 1.16, right? Anybody not get that? Am I going too fast? Have I lost anyone? Okay, so that's a basic one. Let's do another one. If I had log x2 equals 3. Again, I'm trying to solve for x, so I'll be writing it like this: ln x on ln2 equals 3. Then I'll naturally, because you're trying to solve for x, you're going to multiply this guy over. So ln x equals 3 ln2. And then can anyone tell me what I'm going to do with this 3 that's at the front?
Put it
What
as a
can I do
power.
with? Yeah, that can go as a power now. So you're doing the opposite of that. So that becomes 2 cubed. So what you're left with is this. ln x is equal to ln 2 cubed, which is 8. And Lysandra, do you know what x equals to by just reading it like this?
No.
No, hold on. Wait, listen. ln x equals ln 8. What should x equal to for this equation to be equal?
8.
Yeah,
Okay.
right. It's going to be log 8 equals log 8. You're just balancing. Now, if I take away the logic, and I'll teach you how you're meant to do it. If I've got a log on one side and a log on the other side, well, it doesn't matter on the other side. If I've got a log x on this side, how do I get rid of the log, Lissandra? What's the opposite of logging?
Exponential.
Exponential. So you exponential both sides, and exponential and log cancel out, right? That's the whole point. They're the opposites. So what are you left with? X equals
8.
8. Just like the same as you would have said this. Sine x equals 8. Now, how do I get rid of sine? You would have said, hey, shift sine or inverse sine. What you do to one side, you do to the other. You'd write x equals inverse sine 8. Exactly the same. The opposite of log now is exponential. Opposite of an exponential is logging. So we've got this question. 2 to the x equals 7. That's an exponential. And I want the x on the top. How do I get rid of an exponential? What are you going to do to both sides? Rad, what would you do to both sides?
Try and make the bases the same.
Oh, yes, for term 1. Like what you just finished, yes. But you can never make a 2, you can never make a 7 into a base of 2.
Yeah.
You're going to be there, it just won't work. It won't work.
Yeah, for sure.
How do I get rid of the exponential? What's the opposite of an exponential?
A log.
Log. So what do you do to both sides?
Log them.
All right, but let's go back here. How do I get rid of the log? We said exponential. Cool? This is an exponential. How do I get rid of an exponential? Log them. So now you've got this. What are you allowed to do now with the x?
Drop it.
Ah, look, it was so hard. But look what you've just done now. You brought the x down. That's nice and easy. How are you going to get rid of this log 2? Be careful. You'll divide by log 2. Because you're not just getting rid of the log, right? This is a number now. Do you understand that?
Yep.
And that's the answer. Plug that into your calculator. You should say 2.807.
Yep.
And if you guys want to check it, if it's true, do 2 to the power of log 7 over log 2. And that should give you 7. That's the actual answer for x. And that's what I mean by proving it. So your teachers might have gone from this line straight to this line without any working out. The problem is not all questions are going to be that simple. So you will fail eventually, badly as well. So you might as well learn what you're trying to do. So the opposite of an exponential is to log it now. Now you've learned that. And then you can bring your powers down. That's the whole point, because you don't want the x on the top. It's really hard to solve for x on the top. And then you're just going to divide by this log 2. Just like any other number. All right. Any questions? Anyone? No? Okay, let's move on. Let's try this one. 2010 North Sydney Boys Extension 1 Prelim Yearly. So top 10 selective high school in the state. Their exam question from the Extension 1 exam, because it used to be part of the Extension 1 course as well. But anyways, Rewrite 2 to the x equals 5 to the y with x on y as a subject by taking logs to the suitable base. Okay. We want it as x on y, so definitely not these powers. What are you going to do to both sides?
Log.
Log both sides. So what do you write?
Log 2 to the power of x equals log 5 to the power of y. Then you drop
And then what do you drop the powers? And then you're very close. And then
divide.
divide by what?
What do we need?
Trying
X
to
and
get-
y. I put
you're
y
trying
on
to-
the other side, and then ln
Yeah,
5 over
yeah.
ln 2.
Good algebra. Right, well done. So you've got this, you just bring the y over because you just wanted x over y. And then log 5, you bring the log 2 over, so it becomes log 5 over log 2. Done. 1 mark. Anyone have any questions there? Double I. Hence or otherwise, find the exact value of 8 to the x on y if 2x equals 5y. 8 to the x on y if 2x equals 5y, which equals 8 to the power of what? X on y is log 5 on log 2. Just plug it into your calculator and you're done. Tell me an answer. That was easy, 2 marks.
$125.
Yeah, I thought so. 5 cubed, 125. All right. Easy, easy stuff. What's the time? Okay, I think you guys are doing well. 5:07. Yeah, I'd rather do these ones first instead of exponential equations. All right, let's do log equations still. You guys are going to do this. All right, so have a read of this. 2 log x sub base 3 equals log 6 take away x sub base 3. Now, I'm going to write something for you here. So I'll rewrite these using the sub bases. So it's important that you understand them like this. But once you get comfortable and really understand that these sub bases are the same, if they're the same, then it's always going to look like this, which means that if I've got them on both sides, I can just cross them out. Right? You guys probably remember that from your algebra. If they're on both sides and they're fractions, like you can just cross them out because it won't make a difference when you cross multiply. You just start cancelling out. So in this case, I could have also crossed them out. So the answer you're left with is 2 ln x equals ln 6 take away x. You are not allowed to exponential until it's just a single log. So it's got to be monic. You can't have the 2 in front. So what are you going to do with the 2? Bring it up as a power. Exponential both sides, or just get rid of your logs. It depends on how you guys start to see it for yourselves. Bring everything to one side. Well, that looks familiar, doesn't it? Then we have to check. Check means sub each one in. When you sub in 2 log -3, log -3 will give you a math error. So x equals -3 won't work. Therefore, and the only answer is going to be x equals 2. That will work. 6 take away 2 is 4. I can see it working. So your only answer is going to be x equals 2. You've got to check with logs because they're not perfect. You can't log negative numbers. I'll give you guys maybe a minute or two to just think about this. Think about how you would solve it. Maybe, subtraction, that's a log law. And you'll get rid of your logs. Just play around with it before I start, I guess.
Same as the answer 4.
Is the answer 4? Well, 16 take away x, so 16 over 4 is 4. 8 take away 4 is 4. Yeah, the answer is 4.
Beauty.
Yay. Anyone else that actually got 4? Yes, Raj, you're doing well then. Log 16 take away log x, well that becomes log 16 on x equals log or ln, whatever, doesn't matter. Cross out your logs because you will technically exponential both sides. 16 on x equals times by x. Bring everything to one side and factorize and solve. Girls, you comfortable with that? You see, I haven't really done anything, I mean, too crazy, I believe. We used your log laws and then crossed out the exponentials, brought it to one side, start solving, x equals 4. Any issues? Cassandra, Josh, Vinesh, all good as well? All right. 2019, so this is last year's question. Find the value of x if log 2 plus 2 log x minus log 6 equals log 3. Again, all the a's are the same, so if I'm going to divide them by log a, log a, log a, log a, technically you can just cross it out from the first line. So you might as well ignore it. So what you're left with is log 2 plus 2 log x minus log 6 equals log 3. Let's try it again. I'll give you a minute or two, think about what you would do. For you to be able to plus this, that 2 cannot be there. So you can't have a plus when there's a 2 still there. You can only plus when there's a log with a log and a log, just so you know that. So it has to be monic again. That's my clue for that one. Try to play around with it. If you have absolutely no idea what's happening, please let me know now, so I can fix that up.
I'm very confused.
Are you very confused about this top question as well?
Yeah, kinda.
How can you then tell me? So wait,
Oh,
the first step, 16 take away log 16 take away log x. Do you get how I got the division there using our log laws?
yeah.
And then I've got log 16 on x equals log 8 take away x, and then I get rid of the logs by exponentially. Go on. Right, you can write ln here instead of log, that's fine. And then you're just left with this. And then multiply by x, bring it all to one side, start
Wait.
solving.
Okay, so for the E, it
Well,
just comes out of nowhere.
Yeah, no, that's the opposite. It's like you saying 16 on x square root. How do I get rid of the square root?
Square it.
But that's coming out of nowhere. But then that's
Okay.
opposite. So it cancels out.
Okay.
It's the same thing. What's the opposite of log? Exponential. So it's opposite.
Sure.
You get it? All right. So here, log 2 plus 2 ln x minus log. Okay, a whole lot of things. You're not allowed to have the 2 there. It has to be monic. So what are you going to do first with the 2?
Divide it.
This 2, no, you're not going to divide it. No, that's wrong. Because then you've got to divide everything by 2. And that's going to look like a mess. It's attached to the front.
Would you bring the 2 up and make it a power to x?
That's it. So you would bring the 2 up. Does that make sense to you?
Yes.
Because if the numbers are in front, for log, they can become powers. That's the log law.
Yeah.
You get, like I
Okay.
said, the first lesson is always going to be like that. Like it's more like, oh, okay, Then the second lesson, you'll just go, it's a fact, so you'll take it as it is. When they're plussed, what are you going to do?
Mm,
When you
Times.
add two, yeah, there we go. And then when you subtract two logs, what are you going to do?
Divide them.
Now you've got log equals a log. Now, what can you do to your logs to get rid of them?
Divide by log.
No, you can't divide by log. You exponential that. To get rid of the log, you exponential it.
Okay.
If I had this, let's just get it clear. I want to get rid of, now listen to the difference in questions. So it's just your algebra bit that's confusing me. Sine theta is equal to 2 over 4. I want to get rid of just the sine. What's the opposite of sine?
Um,
Inverse sine,
oh, right.
right? Or shift sine. That's the opposite. That's how you get rid of the sine. But if I said to you now, and listen to the question, how do I get rid of sine 40? You're not allowed to say inverse it because you're
You have
not
to
getting rid of the sine. You're getting rid of the number. So that you would, what you're saying, you'll divide it.
Okay.
You get the difference? So when
Yeah.
I'm saying here, in this question, I'm saying, how do I get rid of the log? I'm talking about just the log. I'm not talking about anything that's attached to it. If I said, if I said here, how do I get rid of log 6? What would you say? How do I get rid of log 6 to bring it to this side?
To divide.
No, it's minus log 6. How do I bring it to this
So you
side?
just plus
Yeah,
operation.
you
So
would plus it.
okay.
Yeah, that's the idea. So it's just a number, log 6. You plug it into your calculator and it gives you a number. Cool? You'll get that. But yeah, here, opposite of logs, exponentials, you got rid of it. X squared on 3 equals 3. I think you can continue from there. X equals -3 won't work. Therefore, only answer is x equals 3.
Sam, why wouldn't x negative equals -3 work?
Good question. Sub it in. 2 log -3. Sub it into your calculator. 2 log
It's a
-3
math error.
gives you math error.
Okay.
If it did work, absolutely put it in. Like if this was 6 take away x instead of x, let's say, what's 6 take away -3? Well, that becomes 6 plus 3, which is 9. X equals -3 would work now. But yeah, but because it's x, it just won't work.
Yep. Okay.
Eden, talk to me. We're gonna do more.
Okay.
I'm not gonna move on. Just
I get it. I think I
You
get
get
it.
do another
Yeah.
question. That's it. That's the best way. Instead of me making up one and it doesn't work, and then you guys are going to kill me, I'd rather just. Okay, there it is. Let's do all of these. Okay, we'll start with the first one. Eden, you can be the first one. 2 ln x equals log 4x plus 5. I would love to have just got rid of the logs, but I'm not allowed because this is not monic. So what's your first line? You're not allowed to have the 2 in the front.
Can you divide by 2?
You can, but it's not going to do much because look, now you're going to have this all over 2. What's in front of the log? 1 over 2. So it's equally not good. Can you see that? Like your logs must be 1s only. Must be mono.
Okay.
So you're saying divide by 2, you can't do it, but it didn't help you. You're allowed to bring your 2 to a power. You keep forgetting. And then you're here. What are you going to do now with your logs? Because this is a log.
Cancel.
Yeah, you
Yes,
can technically.
exponential.
Yeah, you can technically cancel. I mean, you will never see me write E and E. You can just cancel because you know they're the same now. But you can't cancel here. Okay, can't cancel at that stage. Only at this stage. But exponential is if you want to know what you're doing, the opposite of. All right, you're left with x squared equals 4x plus 5, and that's it. After that, it's easy. What must you do when you got your final answers?
Put it into the
Check them.
calculator.
Yeah, check it, right? And I can tell already log of -1 is going to be a problem. So x cannot equal to -1. That's going to be a problem. Therefore, the only answer is x equals to 5. It's going to be a problem when you sub in -1 in here. Double I. All right, Eden, you want to try it again?
Yes.
All right, double I. Log x plus 3 minus log x minus 1 equals log 3. Okay, log 3, I think we can agree there's nothing wrong with it. Just leave it. Log something minus log something. Log, what are you going to say?
X plus 3 over x minus 1.
Bingo. And then log and log, what are you going to do?
Cancel them.
What are you left with?
X plus 3 over x minus 1 equals 3.
And then just do it. And 2x, 3 plus 3 is 6, so x equals 3. Even when you get x equals 3, don't be so happy. Like, always learn to sub it back in, because even if you solve for this, if it doesn't work when you sub it in, it could be no solution. But I can see that would work. 6, and that's 2. 3 take away 1 is 2. And so that's not going to be a problem. Triple I. All right. Trickier one. Lissandro, let's do this one.
All right.
Now, the reason why I said it's trickier is because with the other ones I said this is a 7, this is a 7, and this is a 7. So I can just cross them out. This is a 3, this is a 3, this doesn't have a log 3. So I can't cross them out.
All right.
Okay?
Yeah.
I've got to write these as fractions. So it's going to be like what? ln
X plus 1 on 3.
on
ln 3.
ln 3. Be careful, not this version. It's not, you're not subtracting 2 logs, which becomes x plus 3 on x minus 1. This is log of this over log of this. All right, all good. Log of
X minus 1
on,
ln 3.
perfect, equals,
2.
beautiful. Then you can see the common denominators of log 3, obviously.
Yeah.
So what are you going to do with your common denominator of log 3? Usually, you would?
Put them onto one fraction.
Yes, you would. And then eventually?
Multiply it.
Yes,
By 2.
That's it. So eventually you bring it to the other side because you don't want fractions.
Yeah.
So I hope that you can do it in this one line, like this. There. Are you comfortable with that?
Yeah.
And then minus, what are you going to write next?
ln
Yes.
x plus 1 on x minus 1.
Equals. You don't want the 2 there.
Put it up top.
Log of 3 squared. What are you going to do with your logs?
Exponential.
And then, can you see you're done?
Yeah.
Because after that, it's just x plus 1 on x minus 1 equals to 9. And that's really easy to solve. Good work. Go back, see if there's any questions that you've got. Anybody else have any questions for us? Eden, does it make sense? Everything that we've done?
Yes.
100%. All right, then this is what you'll do. After today, you'll go back to the recording, I think maybe tomorrow. That's what I would personally do. And just recap everything. And if you've still got questions, join the Saturday class. Again,
Okay.
and just we'll recap all this again.
Yeah.
Cool. And that goes for everybody. Anybody that's that guy still feels like, oh, this is not perfect, we can do it again on Saturday. And I usually do a different booklet with those guys, and then I send their videos to you guys and your videos to them. That's probably what you guys are seeing throughout the week when I'm sending extra videos to you guys. Okay, IV. Josh, let's do IV.
Yep.
A little bit different to triple I because obviously they're all 7s. So just imagine if you were dividing all log 7, log 7, log 7. Essentially, you can cross them out anyways. So just get rid of it in the first line. And then what are you left with?
Would you put the half log, would you put as the power?
Yeah, sweet. And what about the 2 then?
Yeah, you'd bring that up as a power as well.
So what are you going to write? Log?
To the power of 2.
So 4 to the power of 2.
Yeah.
Equals?
Log to the power of half.
Say it properly. Log of?
Log of, I can't see the number. What's this?
X.
Oh, yeah, x.
To the power of half.
Plus
log
to the, just 2.
Just 2.
Yeah.
And then? Plus?
You'd put that as, like, just times each other. And, yeah, you can cancel them out now, would you? And then you're just left with the thing, yeah.
And then? Next line? You're solving for x. Don't overthink it. Solve.
Square it.
Oh, not yet. You're solving for x. You got to, before you square it, you got to get rid of this thing.
Take away 2.
Take away. You sure?
No, oh no. I'm having a mental blank.
They're multiplied. So
yeah, times it, yeah.
Divide.
Oh no, I was talking about the 2 on x.
Yes, they're multiplied, so you got to divide it. And then, now you're at this stage. You square it. Yeah.
Oh.
Square root x, you square it now. X equals 64.
It's just only remember it. Yeah, crazy with it.
All good, all good. Let me see, 2 ln x plus 2. Equals log 2x plus 1 plus ln 8 minus x. All right, Lisa, let's do this.
Okay.
This one's a hard one, so let's go.
Alright.
What are you going to do with the 2?
You make it a power.
Yep, so this side's pretty much done.
Mhm.
They're plus. What are you going to do?
Times them.
So how do you write that?
2x plus 1 times x minus 8 minus x.
Like this? Did you ever write
In
your
brackets.
times like this? Yes. All right. And then what are you going to do with this when you're going to expand it? Yeah.
Yeah.
And then what can you do with your logs?
Cancel them.
If you guys keep doing it the way I've been showing it to you, you can see it gets pretty repetitive with your algebra. But okay, good. And then x squared plus 4x plus 4, 16x, take away 2x squared plus 8, take away x. Bring everything to one side. So x squared plus 2x squared is 3x squared. 4. That's 16 take away x is 15. So 4 take away 15 is negative 11. 4 take away 8 is negative 4. And what would you do at this stage? Factorize or quadratic formula?
Quadratic formula.
Yeah, I think so. I can probably see it, but I think it's just a safer option to just jump straight into quadratic. 11 plus minus square root b squared minus 4 times a times what?
Isn't it?
So b squared minus 4 times a times
C?
c.
Yeah.
Boom. And then plug that into your calculator. 121 minus 4 times 3 times negative 4 is 169. Square root that is 13. 11 plus 13, 24 over 6 is 4. 11 take away 13 is negative 2 on 6 is negative a third. Let's go back up and check negative a third. Negative a third plus 2, that's not a problem. 2 times negative a third plus 1 shouldn't be a problem. So negative a third works. There's no issues with that. 4 plus 2 is fine, that's fine, and that's fine. See this one? Both of your answers are fine. So it's not like the other ones where the negatives weren't working. This one, when you sub it in, if you guys want to go ahead and try to sub it into this, you'll realize your negative a third won't be an issue. All good?
Yep.
Perfect. All right. No question? All good? All good, all good. Now we're up to exponential equation. Yeah, I think this one is a little bit easy to continue. So, all right. That's pretty much log equations. And now let's look into exponential equations. Okay, so there's a big difference in the way we start. So log equations, you know, you got to do log laws and blah, 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 blah. With your exponential equations, they're actually quadratic equations, only hidden. Can someone say that that becomes a quadratic? Maybe you might see it better if I said this. Let m equal to the middle term. So if I said m, let m be e to the x. Well, that means this becomes what? Negative 4m. Negative 4m plus 3. What happens to this bit? Ex all squared. Ex all squared. Isn't that Can we actually see that? I can't move on until you guys can see that substitution.
Yep.
Anyone not able to see that substitution? You got to say it right now, because all of them are going to be quadratic equations just hidden.
Yeah, I see that.
Beautiful. And the trick to it is it's always going to be that middle term. So if you're ever confused about what you're trying to do, just know, first thing, as Sam said, it's always going to be a quadratic equation. And the second thing, do you let your variable, your m, let's say, be the middle term, and then just a simple substitution. Then you'll solve. So you get m equals 3 and m equals to 1. You obviously weren't meant to solve for m. What letter were you solving for? You were trying to solve for x.
Oh, X.
X. In E is just a number as well. E is just like pi, just so you guys know. So pi is 3.14. E is about 2.17 or so. If you want to see what E is, just press Shift LN. It'll say E with a number on top and just put 1. 2.71, sorry. 2.71. 2.71828, blah, 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 blah. So if you want to check out E, you press Shift LN, and then just as a power, just put E to the power of 1. So it's just a number, just like pi is a number. So you're not solving for E, you're solving for X. So instead of M, you replace M for E to the X. You replace M for E to the X. And then, how do I get rid of an exponential?
Log it.
Log both sides. Log both sides. So, Lissandra, do you remember what happens to the x when you log both sides like this? Power.
Goes down.
Yeah, you don't want the power up there, right? That's the whole point. So you're going to bring it down. You're left with log e equals log 3. And then you divide the log e. And then you plug this into your calculator. And just so you guys know, log of e, because they cancel out, it's always going to be just 1. But I thought to not confuse you guys, because this can be any number, it's always just going to be log of that number, and you're always going to divide. But log e, you guys know, should cancel out, so it's just 1. Log both sides, you bring it down, log e is just 1, log 1, the log 1 we know is 0. So one answer is log 3, the other answer is 0. Did I lose anybody there? Log both sides, and then power down, and just divide. Eden, do you understand that? The power down? Why I brought the power down? Because once you've logged both sides, that becomes a log. What are you allowed to do with logs and powers? You can bring the power down. And that's the whole point of why you're even logging in the first place, because you can't solve for powers. But once you bring it down, you can start solving like normal. Okay. Let's do it again. Double I. E to the 2x minus 5e to the x minus 6 equals 0. Can anyone tell me what this is? E to the 2x. What's actually hiding there? E to the x to the power of what?
All squared.
Why?
Because power times a power, they multiply.
Oh, good man. Power to power is just multiplying, so you get 2x. So technically this is your ex squared. It's just hiding. So this is actually exactly the top. But you guys know that because I've already told you these must be quadratics. So yes, good work. That's just like ex all squared. So again, you just let m, or whatever letter you like, maybe the letter of your name if you want to choose that, let m equal to ex, and then just go m squared minus 5m minus 6, solve. Replace. You're not solving for m. Log both sides. You can't log a negative, so there's no solution for this one. This one here, log e is just 1. So your answer is just log 6. Copy that down. Let me know if you've got any questions. And then we're just going to pretty much do another 2 and we're done with logs and exponentials for today. No questions? All right. Let's do these ones. Who wants to give it a shot? What should m equal to? Obviously, you guys should be able to tell straight away that's an exponential equation compared to a log equation. There are no logs. That's obviously an exponential equation. Who wants to give it a shot for m?
Is m equals 3x?
You are correct. And then this becomes what?
3x to the power of 2.
You are correct as well with that, which means when I'm going to sub in m, this becomes what?
M squared
Beautiful. Minus 12.
times m.
Yes,
12
yes. Plus
7.
27. And then factorize. 27, 12. 9 and 3. Take away 9. Take away 3. M equals 9. M equals 3. 3 to the x is 9. 3 to the x is 3. Some of you might be able to already tell the answer. Does anyone know the answer straight away from x and what x is here? 3 to the power of something is 9. 3 to the power of something is 3.
2 and 0?
1, you mean?
Yeah, 1, sorry.
3 to the 1 is 3, and 3 to the 2 is 9. But for any reason you didn't know that, you could just log both sides, because now you've learned that, which is a lot more powerful. You get x log 3 equals log 9, and then just divide. Go plug that into your calculator, you'll see it become 2. Oh yeah, I did say to Eden, I will prove this. There it is. You see these ones here that we just learnt, it's 1. But you now know the formula for this, which is log 2 over log 2. And that's why it's always going to be 1. It's because it's just logging something over the same thing. You're dividing the same number by itself. But yeah, easy. Any questions there? No. These ones you don't need to check, so exponentials have no problems. You won't need to check answers, it's just for logs. Okay. 4 to the x. That's a tricky one. That's hiding. 4 to the x. Anyone tell me how 4 to the x is hiding?
Would it be 2 squared and then x?
And then that's not really what you want. You know that can also be written like this, right? You can just swap 2 around, and then there it is. It's hiding. 2 to the x all squared. Exactly like I said. Your m is always this term here, and then that's pretty much going to be hiding. So m squared take away 12m plus 32. All right, you guys go and finish it off. I'll be right back. Okay, so 32 16, no, 8 and 4. M minus 8, M minus 4, M equals 8, M equals 4, 2 to the x equals 8, 2 to the x equals 4. Again, you probably, for these ones, you can see the answer, but who cares if you can't? Just learn to log. X equals log 8 on log 2. That's essentially where most students get to. They just go a log of this side over log of this side. Any questions? Okay. I am happy with that. So